I really like this slide for one reason. It's going to go through everything and how to transform a point step by step, and it's eventually going to develop a final mapping right over here. Big thing to remember, don't forget your SRT, okay? So first thing here, it says, how do you describe the following transformation? Okay, easy peasy. First things first, let's look at the restriction. Always look at that restriction first. We know that 2x minus 4 has to be greater or equal to 0. Bring the 4 over. 2x has got to be greater or equal to 4. Divide by 2. Divide by 2. X has got to be greater or equal to 2. Okay, perfect. No sign changes or inequality changes or anything like that. So we know that we're going to start at 2, which also means, don't forget, this is not in the right form. Let's put it in the right form by factoring out that 2 right now. So I'm going to say y plus 3. There's the negative 4, right? Okay. There's the square root of 2x minus 2. Aha. Okay. So don't forget our SRT now, because this follows the rules of BEDMAS. And that's really going to help us out when we're figuring out our final mapping. Okay, let's go step by step. What's the first thing that happens? Well, let's identify our A, B, H, and K. And then we can start working from there. Our A, of course, is negative 4. Our B, we figured out here, is 2. So that's actually going to be a half, right? Our H is going to be moving 2 to the right. So it's plus 2. And our K, of course, bring that over to the other side if you want to. Or if you're smart, you realize that that's a negative 3. We're going down 3. So let's go step by step here, okay? So what are the actual steps that we're going to be working with here? Okay, so first things first, let's talk about this A value, okay? We know that that A value is going to give us a vertical stretch, okay, of 4. Now, I'm not including the negative because we even said stretches first, reflection second. Okay, so vertical stretch of 4. So what's going to happen to our coordinate point? That's what I want you to notice. Our coordinate point is going to become x, comma, remember, verticals affect the y. So this is going to be a 4 times whatever our y component is. Well, that's easy. Now, let's do the reflection next. That's this guy. Okay, so let's reflect. So this is going to be a reflect over, remember, if it's vertical, just draw a coordinate out. Vertical, it's going to be over the x-axis, okay? Over x-axis. Oh boy, running out of room here. I write too big. So now we can incorporate now what's happening to this guy. So that means that all of the y values are going to be multiplied by negative. Interesting. Okay, now we've taken care of our A. Let's now go to our B. Our B then, we remember that this is also going to be a stretch, but this is going to be a horizontal stretch. Okay, I'll factor not 2, I'll factor 1/2. And remember, horizontals now affect only the x-axis. So look how this is evolving. Our x-axis now, because of course stretches first, is going to be 1/2 times x, right? And that minus 4y is just going to be carried along. All right, what's the next thing that we have to do? Well, is there a reflection horizontally? No, it's a positive value. So B is taken care of. Let's go to the H value now. The H value, which we know is here, right, of 2, that is a horizontal. So let's look at this. We're going to say that this is a translation, okay, translation of 2 to the right. So moving left and right is, of course, an x component. So what this is going to become is this is now going to evolve again. This is now going to be 1/2 x. 2 to the right means add 2, and I've still got that minus 4y that carries along here. Interesting to see how that mapping is developing over the next couple of transformations. Okay, let's go to K. Finally, K, here it is. K says, we're going to translate again, but now we're going to go 3 down. 3 down. So how does this mapping turn out? Well, take a look. This is going to be still the 1/2 x, right? This is still our movement of 2 right. This is still our reflection and our stretch of 4, okay? And now we're going down by 3. Guess what? There's our final mapping. Oh, cool. So all I have to do then is take this guy and just write it up here. Yes, exactly what we have to do. This is going to be xy gets mapped to 1/2 x plus 2 minus 4y minus 3. There's our new mapping. So that mapping is now like a formula that helps us take every single point on a graph and change them. Okay, let's see how they change. I'm going to keep that guy kind of right there so you can see him. Well, actually, I'm going to have to rewrite it. 1/2 x plus 2 minus 4y minus 3. That's our mapping. Okay, so that takes every point xy, that's why we have it written here. Take every original point, apply this formula to it, and you'll be just fine. Okay, let's make that look more like a 2. There we go. Okay, let's look at the original points. Bada boom. I wrote out the original points. Remember, original graph is y equals the square root of x. And you can do this with any polynomial in the world, right? As long as it's a function. Okay, it'll follow this, no problem. So we said first point, of course, was 0, 0. Then I typed in 1, 1. Another one is 4, 2. And if you want, you can put down like 9, 3 here and so on and so forth. Those are all based on this wonderful function. Now, let's figure out the map points. Let's start here. Starting with 0. Okay, put it in. For the x, half of 0 is 0. Plus 2, guess what? Our new point is 2. There's our new endpoint starting up. Ah, interesting. Let's put in the 0. Okay, 0 goes in here into the y's. 0 times -4, 0. Minus 3, minus 3. There's our new point of 2 minus 3. And we can put that right on the graph right now. There's our new endpoint. Interesting. Okay, now let's keep on going to the next one. 1, 1. Remember how we did this in the last question? We used 1, 1 and we figured it out. Let's do exactly the same thing here. Look, put it in there. Half of 1 is a half plus 2. I'm at 2.5. Interesting. Yeah. Now, let's do the same thing to this point here. Put it in right here. -4 times 1 is -4. Minus 3 is -7. Neat. Okay. And then now let's look at the last point, which is 4, 2. Okay, same thing, same thing. Let's pick another color here. I will pick red. There we go. 4. Pop it in there. Half of 4 is 2 plus 2 is 4. So that's 4. Okay, pop in the 2 now. -4 times 2 is -8. Minus 3 is -11. And honestly, after you get about the third point, you really don't care. I mean, the rest of them are going to just follow. So look at this. There's 2.5 minus 7. Let's put that in there. 2.5 minus 7 looks like right about there. The next one is 4 minus 11. 4 minus 11, look at that. It's right at the edge of our graph. And you can see the pattern of the graph is starting to go down kind of like that. And it's going to continue on in that direction. So mapping, determining the mapping like this can really help if I give you a whole bunch of coordinates and say, where are those new coordinates on this new transformed graph? I think it's pretty cool.